Is the universe really that vast? Shocking comparison to a 30 centimeters pizza. What can the pizza you're eating today teach you about the universe? Sounds strange, doesn't it? But if the universe were a giant pizza, then we, humanity, would just be a tiny piece of topping. So how vast is this pizza? Let's explore. Let's start with pizza, a familiar and appealing dish. Imagine holding a large pizza in your hands, about 30 centimeters in diameter, big enough to share with friends or enjoy alone in a relaxed meal. A pizza is not just food. It's a relatable symbol that helps us connect with bigger ideas. If this pizza represented the universe, our Earth might be no more than a tiny peppercorn quietly resting on the topping. In this pizza, every slice, every layer of cheese, or piece of sausage could represent planets, stars, and galaxies. Looking closer, the pizza crust could be likened to the foundational space of the universe, where everything exists. The vibrant red tomato sauce symbolizes the light from billions of stars burning in galaxies. Meanwhile, the melted cheese and toppings above are all celestial bodies, from planets and asteroids to the mysterious matter we've yet to discover. Interestingly, if we zoom out even further, this pizza would only be a small part of a much larger table, a cosmic feast of countless pizzas, much like how galaxies cluster together in the universe. So, where do we stand in this perspective? Humanity, with all its intellect and curiosity, is but a minuscule speck in the topping. Carl Sagan once said that our Earth is a pale blue dot in the vastness of space. This imagery helps us grasp our smallness while opening up the possibility to explore and understand the vast universe. When we talk about distances in the universe, they often surpass the limits of human imagination. Let's start close to home, Earth, and consider the journey to the nearest star. Proxima Centauri. Proxima Centauri, part of the Alpha Centauri system, is about 4.24 light-years away. At first glance, this number might not seem too large, but in reality, this distance is far beyond humanity's current travel capabilities. Imagine boarding the fastest spacecraft humans have ever built, NASA's New Horizons probe, traveling at about 58.000 kilometers per hour. At this speed, it would take over 80.000 years to reach Proxima Centauri. 80.000 years. This means that if ancient humans from the Stone Age had started the journey, their descendants would still be en route today. Meanwhile, light, traveling at 300.000 kilometers per second, takes just over 4 years to make the trip. This is why light years are the standard unit of measurement in astronomy. Distances in space are simply too immense for conventional units like kilometers. Here's a more relatable example. Suppose you're holding a large 30 centimeters pizza with toppings representing planets and stars. If Earth is a tiny peppercorn at the center, then the peppercorn representing Proxima Centauri would need to be placed hundreds of kilometers away from the pizza. This comparison helps illustrate the unfathomable distances between stars. Even in our immediate neighborhood, while Proxima Centauri is the closest star, reaching it remains an unfulfilled dream. Interestingly, Proxima Centauri is not just a star. It has an orbiting planet named Proxima b, which is a potential candidate in the search for extraterrestrial life. But even if we discover a way to reach this planet, could humanity endure a journey spanning tens of thousands of years? This challenge has inspired scientists like Stephen Hawking to propose using light sail propulsion technology to achieve speeds close to the speed of light. With such technology, the journey to Proxima Centauri could be shortened to a few decades, a promising future, though still beyond our current capabilities. The distance between Earth and Proxima Centauri not only highlights our smallness in space, but also serves as a reminder of the universe's vastness and mystery. Even when faced with seemingly insurmountable journeys, humanity continues to search, explore, and dream. This relentless curiosity is what drives us to reach for the stars. The Milky Way, the galaxy we call home, is a magnificent and complex structure that's almost beyond imagination. To make it easier to grasp, imagine the Milky Way as a gigantic pizza with a diameter of about 100.000 light-years. If you were to slice this pizza into 100.000 pieces, each slice would represent 1 light-year, the distance light travels in a year, approximately 9.46 trillion kilometers. This number is not just massive, but also a reminder of how tiny we are within the universe. This Milky Way pizza is not just a simple flat surface. Instead, it has a spiral structure with hundreds of billions of stars. The spiral arms, like vibrant pizza slices laden with colorful toppings, are where most of the stars, planets, and cosmic matter are concentrated. Meanwhile, at the center of this gigantic pizza is a special filling, a supermassive black hole known as Sagittarius A star. This black hole is millions of times the mass of the Sun and acts as the glue holding the stars of the galaxy together. Much like cheese binds the toppings on a pizza, Earth and our solar system are located on the outskirts of a spiral arm called the Orion Arm, approximately 27.000 light-years away from the Milky Way's center. This is like sitting at the edge of a giant pizza, far from the dense, cheese and sausage-filled center. But this peripheral position provides safety. If our solar system were closer to the center, radiation from the supermassive black hole and the densely packed stars could render life on Earth impossible. Now, think even bigger. While we live on this Milky Way pizza, it's just one among billions of other pizzas in the universe. These other pizzas are galaxies, each containing hundreds of billions of stars. Together, these galaxies form an intergalactic feast in the cosmos. Unlike a neatly arranged dining table, these galaxies are gravitationally pulled together, forming galaxy clusters and superclusters. Our Milky Way, for example, is part of the local group, which includes about 54 galaxies of varying sizes. So, if the Milky Way is just one slice in this enormous galactic feast, how small is Earth? A single slice of this cosmic pizza contains billions of stars, each potentially hosting its own planetary systems. Within the Milky Way alone, billions of planets exist in the habitable zone, regions with conditions suitable for liquid water. This raises a profound question. Could there be someone else living on their own cosmic pizza, gazing at the sky and wondering about us? Carl Sagan once said, "The universe is all that is, ever was, and ever will be." When we think of the Milky Way, the colossal pizza we belong to, is not just a physical structure but a reminder of the wonder and vastness of space. From our tiny edge of this pizza, humanity has embarked on a journey of discovery, sending missions into space and seeking answers to the grandest questions. Though we are but a minuscule part of it all, humanity's aspirations are anything but small. The observable universe spans about 93 billion light-years in diameter. But that's only the part we can see. In reality, no one knows whether the universe is truly infinite or if there is some boundary beyond our observational limits. If the Milky Way is a giant cosmic pizza, the rest of the universe resembles an endless banquet table, where each pizza represents a galaxy, and no one knows how far this table stretches. To imagine it more vividly, consider that this cosmic pizza doesn't just have a circular shape but extends so infinitely that every edge seamlessly connects, creating an endless tapestry of galaxies and superclusters. These galaxies aren't stationary. They're constantly moving farther apart due to the expansion of the universe. This phenomenon was discovered by astronomer Edwin Hubble in 1929, which is why the universe today is more vast than ever before. This immense universe is not just a physical space but a repository of the greatest mysteries yet to be solved: the nature of dark matter, dark energy, and the ultimate questions about the origins and purpose of our existence. In this enormity, humanity is but a speck of dust floating amidst the infinite sea of space. Yet, this very insignificance inspires us to dream and explore, making the universe an endless source of inspiration for our imagination. Throughout history, humans have always sought to understand the universe and their place in it. One of the most notable stories is that of Galileo Galilei, the 16th century Italian astronomer who revolutionized how we perceive the cosmos. When Galileo declared that Earth was not the center of the universe but merely a planet orbiting the Sun, he faced fierce opposition from the Church. His heliocentric model, based on observations through a telescope he built himself, challenged long-held beliefs that placed humanity at the center of everything. It's astonishing to think that one man, armed with a rudimentary telescope, could spark an entire scientific revolution. But Galileo wasn't the first to question our place in the cosmos. Centuries earlier, Around 260 BCE, the Greek mathematician and astronomer Aristarchus proposed that the Sunday, not the Earth, was at the center of the universe. However, his ideas were overshadowed for centuries by Ptolemy's geocentric model, which positioned Earth at the center, with all celestial bodies orbiting around it. It wasn't until the Renaissance, when Nicholas Copernicus published De Revolutionibus Orbium Coelestium in 1543, that the heliocentric model was revived. This laid the foundation for later discoveries by Galileo and Johannes Kepler. Another remarkable figure was Johannes Kepler, the German scientist who not only supported Copernicus' heliocentric model, but also used mathematics to describe planetary motions as elliptical rather than circular orbits. Kepler overcame significant challenges to develop his laws of planetary motion, which continue to influence science today. In addition to the Western world, other civilizations also developed profound insights into the cosmos. The ancient Maya, for instance, built observatories to track the movements of stars and planets, creating a complex calendar system based on their observations. Meanwhile, Chinese astronomers during the Han Dynasty produced precise star maps and used them to predict celestial events like eclipses. These stories are not just fragments of scientific history, but testaments to humanity's unending curiosity and drive to explore. Across all ages and with every tool, from naked-eye observations and Galileo's rudimentary telescope to advanced instruments like the James Webb Space Telescope, humans have continually pushed the boundaries of knowledge. These advancements not only deepen our understanding of the universe, but also remind us that curiosity and the desire to explore are the very forces propelling humanity forward. The universe is far too vast for us to fully comprehend, but that doesn't stop us from imagining. If you could explore one corner of this cosmic pizza, where would you go? A distant star, a potential planet, or perhaps just an empty stretch of space? Share your thoughts in the comments below. And next time you enjoy a pizza, try imagining where you might be in the toppings. You might be surprised. ****.